Hello, thank you very much for your interest in our research. My name is Tiago, and today I'm going to talk about functional connectivity of the arousal system and its potential role in age-related differences in cortical network architecture. As we know, the activity of the brain is organized in different functional networks, and those networks can work in a manner that's more or less segregated one to another. During the aging process, what happens is that in general, functional networks tend to become less segregated with age, which means that the different network modules become more connected one to another. Despite recent advances in characterizing the effects of aging on cortical networks, a complete understanding of what is causing these changes is still lacking. And one potential cause of age-related declines in cortical segregation may be coming from outside the cortex. The brainstem arousal system plays a critical role in cortical activation and is known to be affected by age. Thus, we hypothesize that age differences in functional connectivity of the arousal system might contribute to the commonly observed age-related differences in cortical connectivity. This is the pipeline of our study, in which we used the resting state fMRI data from the CAM-CAM database. And here in this very short presentation, what I want to highlight is that first, we analyzed the connectivity of the arousal system and cortical networks, followed by a series of mediation analyses aiming to evaluate the mediating effects of arousal system connectivity on connectivity within and between cortical networks. Now, starting with the results, this is the functional connectivity ring of the arousal system, and we found that the arousal system is widely connected to several cortical networks, with positive connections to the default mode network, insula, and inferior frontal gyrus, and negative connections to other regions of the salience network, apart from the insula and the visual network. In chart B, the effects of age, we see that age is associated with extensive changes in the connectivity of the arousal system, mainly increased connectivity within the arousal system itself and decreased connectivity to the cortex. If we look at the connectivity within and between the cortical association networks, as expected, we see strong positive connections within networks modules on the matrix diagonal here. And the effect of age is plotted in chart B, and again, as expected, we see that different functional network modules tend to be more connected one to another, so decreasing network segregation, as we can see here out of the matrix diagonal. To determine if age differences in arousal system connectivity contributed to the observed cortical differences, we ran a series of mediation models. In model A, we tested whether the age-related decline in within-network connectivity is mediated by the effect of age on connectivity between the arousal system and that network. For example, is age-related decline in the default mode network connectivity partially explained by the effect of age on the connectivity between the arousal system and the default mode network? In model B, we tested whether the age-related increase in most cases in between network connectivity is mediated by the effect of age on connectivity between the arousal system and the networks in question. For example, is age-related increase in the default mode network frontoparietal network connectivity partially explained by the effect of age on the connectivity between the arousal system and the default mode network and the arousal system and the frontoparietal network, while controlling for the effects of age on the connectivity within those networks? So now moving on to the results down here, what we found is that first in chart C, the mean effect of age on connectivity within and between association networks. And what we found, as shown earlier, is that the connectivity within networks tends to be reduced and the connectivity between networks tends to increase. Chart D shows the mediation results. And what we see is that the connectivity of the arousal system to the default mode network mediates age-related decline in the connectivity within the default mode network, as we can see here. And the connectivity of the arousal system to the salience network mediates age-related decline in the connectivity within the salience network here, as well as the salience network's decreased connectivity to the default mode network, dorsal attention network, and frontal parietal control network. And based on our results, we can conclude that age-related differences in the connectivity of the arousal system, which is probably caused by disruptions in the neurotransmitter systems, are associated with age-related differences in cortical connectivity.